Everyone, what I'm going to do with you is a real life example for static equilibrium with a ladder. There's lots of different forces, and I wanted to kind of show you how to set up a real example with our real force sensors so that you can actually predict what the force from the wall is and the force from the ground. So materials you're going to need here are the two large force sensors. You're going to need the Vernier Logger Pro, a bar, and a mass. Connect the LabQuest Mini into your computer. Take your force sensors, attach those force sensors, one on the ground. The other sensor I want you to take and put it on the ledge of the dry erase board. Plug both force sensors into the LabQuest. And now you're going to need your pole. The pole is going to represent our ladder. The ladder is going to lean on the bottom force plate and against the wall as shown. What I do recommend in this step here is actually attaching some tape to that bottom of the ladder just in case it wants to slide out. We don't want the entire ladder to rotate. That's the goal of static equilibrium. So putting a little bit of tape there won't mess up our results too much, or not let that ladder move. So now, any location besides the center of gravity of the actual ladder, I'd like you to tie this mass and put it onto your ladder. Once you get the mass onto the ladder, you can hold it there with a piece of tape so that it doesn't slide up and down your ladder. This will represent the person that's going to climb up the ladder, and we can analyze the forces from the ground and from the wall when we set this up. And if you want to have a more extreme example, you can increase that angle. Now I'll demonstrate where all the forces are acting. The force of gravity of the ladder is pulling straight down. The force of gravity of the person is pulling straight down. The force plate on the bottom is pushing up with a normal force. The one from the wall is pushing straight out. And since there's friction acting on the bottom of the ladder, it's pulling inwards. Here's one more view of the entire setup. You can see where everything's attached and how all your force sensors are plugged into your computer. That'll give you force readings on both plates. I'd like you to predict what those force sensors are going to read, and from that, and from our force diagram here, the force sensor that was on the dry erase board will be able to record force 1, and what the bottom force plate will be able to measure is this force down here. Mainly it'll be able to register that normal force. You're going to have to play around to find that force of friction. If you look at my force diagram here, I've got the force of gravity of the ladder, like I said. I've got the force of gravity of the person. Those are my two down forces, and the normal force should be my only up force. That should be what force sensor on the floor is reading. Force sensor on the wall should be reading the force of friction, and from that, we know that friction equals mu times the normal force. So since your force sensors are reading those two variables, you can figure out the coefficient of static friction between the ladder and the floor. Good luck.